Hello everyone. In this session we are discussing about the combinational and sequential circuit, and will be discuss and explain the operation of latches and flip-flops. Then we will be discussing the operation of basic RS flip-flop, then clocked RS flip-flop and clocked D flip-flop. So in this session we majorly concentrate on sequential circuit, and also let us look into the difference between what is a sequential and what is a combinational circuit. So what do you mean by sequential digital circuits? So sequential circuits are those circuits in which your output depends not only on the current inputs but also on the previous state of the output. So the basic sequential circuit elements can be divided into two categories. One can be a level sensitive and the other is edge triggered. So what is level sensitive and what is edge trigger? So the basic element over here is latch. So latch is a storage element which stores either 0 or memory 1. It is also called as memory. A latch is a basic storage element where we call it as a memory. It stores either 0 or 1. So this latch is enabled either with enable pin. So we call it as high level sensitive or low level sensitive. This latch responds to high level, either high level or low level. Similarly we have flip-flop. So flip-flop is once again a storage element. It's a memory which stores either or 0 or 1. Here this flip-flop is triggered by clock, something called clock. So this can be a positive edge trigger or it can be a negative edge trigger. So we will be discussing in detail about this in coming session. So what is edge triggering, what is positive edge and what is negative edge, what is level sensitive, this will be discussing in the coming sessions. So till now we have studied many combinational circuits in the previous session, like multiplexer, decoder, encoders, adders, etc. So till now we have studied all those things. That is nothing but a combinational circuit which has got inputs as well as outputs. So this combinational circuit depends on the present input. Depending on the present input condition, you are going to get an output. So that is nothing but a combinational circuit. So now we are discussing an additional element, that is nothing but storage element. Here we can store the output of the combinational circuit in a storage element. What is this storage element? It is nothing but a circuit which stores an information. We call this as memory. So we can store the possible next state in a storage, and then you can take back or you can feed back the present state to the combinational circuit. Then we can realize what will be the output. So sequential logic circuit remembers past inputs and past circuit state. So output from the system are fed back as a new input. So the storage elements are circuits, as I discussed, that are capable of storing any information. That is nothing but it is also called as memory. So basic element in sequential logic is a bistable latch or a flip-flop, so which acts as a memory element for storing a single bit, 1 bit data. Let us discuss the difference between sequential and combination once again. The combinational circuit output depends only on the present input. Note that it depends only on the present input. But in case of sequential, output depends on the present as well as on the past output. So your sequential is taking care of two elements, that is present input as well as past output. So in combinational circuit, we don't have any memory unit or any memory element to store the bit. But in case of sequential, we do have a memory unit to present what is stored. So the example of combinational circuits are half adder, full adder, multiplexer, decoders, comparators, etc., what we discussed in the previous sessions. In the sequential circuit, in future we are going to discuss about the sequential circuits. The example flip-flops, registers, counters, etc. So these are the differences between combinational and sequential circuit. So let us discuss now what is a flip-flop. So flip-flop is a memory element and it is a sequential circuit which stores a single bit, that is 1 or 0, and it has got two outputs, Q and Q complement. So we have complemented output as well as a normal output on a single flip-flop. One is a normal value and the other is complement value. The basic building of flip-flop, we can take an example of NOT gate. So simplest sequential circuit is represented here. So two inverters or two NOT gates are connected through a feedback. So this is an input to the NOT gate, output to the NOT gate. We have two gates over here, upper NOT gate, lower NOT gate. So the output of upper NOT gate is connected back as an input to the lower NAND gate. Similarly, output of lower NAND gate, NOT gate is connected to the input of the first upper NOT gate. So we have a crisscross connection. This crisscross connection is called as feedback. So this represent a basic bistable element which stores either 0 or 1. So my Q is called as normal output, Q complement. It is nothing but complemented value of the store bit. So either I can apply here 0 or 1. Based on that, I am going to get my output either high or low. So consider here, suppose I am applying a low value here. Right. So output of the first flip-flop will be I, which in turn is connected back to the lower NOT gate as I. So my output of this NOT gate will be low. So together we can say output of this bistable element as I and low, which is a normal output as well as complemented output. So this is a basic bistable element to build a flip-flop. So what is the difference between flip-flop and a latch? Flip-flop samples the input only at the clock event. We are using something called clock over here. So let me discuss what is a clock and what is a enable signal. So any signal which I represent low as 0 and I as 1. So if this is a single pulse, this is called as a pulse. A pulse is represented by a transition of a 0 level and I level back once again 0 level. This is called as a single pulse. Suppose I continuously provide these pulses. So it is a train of pulses is called as clock. Train of pulses is called as clock. So whenever I use a flip-flop, so suppose this is a flip-flop which samples output, normal output as well as complemented output. I need to give the inputs here, inputs, and this represents clock. This flip-flop will respond these inputs only at clock. Whenever I apply clock only, it responds to the inputs and produces outputs. This is in case of flip-flop. So latch. So even the latch has two outputs, two inputs, say. So the difference over here is the signal what I am applying here. The difference between flip-flop and a latch. So this is latch. So flip-flop samples these inputs only at a clock event. latch samples these inputs continuously whenever there is enable. So, enable is nothing but a signal. A signal I am going to give enable as 1. If I am giving enable as 1, so whatever the input I am giving, that is sampled based on the operation of what kind of latch I am using, that is sampled at the output side. Whenever the enable is on, you are transferring the inputs, based on the inputs we will get the output values. So, flip flops are edge sensitive, latches are level sensitive. What do you mean by edge sensitive and what is level sensitive? So, whenever I talk about clock is with respect to flip flop. Enable signal is this, a signal, either it can be logic 1 or logic 0. If I am treating as logic 1, enable signal is I, then only this latch respond. As I said, flip flop will respond whenever the clock signal is I. So, edge triggering. So, let us discuss what is edge sensitive. Clock as 0 to 1 transition, as I said, and I have 1 to 0 transition. So, 0 to 1 transition and 1 to 0 transition. So, if I say 0 to 1 transition, then I call this as positive edge triggering. So, if I say 1 to 0 transition, we call it as negative edge. I mean to say that this flip flop, if I talk about positive edge triggering or negative edge triggering, edge sensitive, this flip flop is sensitive to this edge. So, whenever the clock goes from 0 to 1 transition, then only this flip flop will sample the inputs to the output side. The flip flop will respond to the particular edge. This edge can be either positive or negative edge, that is nothing but edge sensitive. When I talk about latch are considered as level sensitive. So, level sensitive in the sense, this is called as positive level, this is positive level sensitive. So, if I am talking about this, it is negative level sensitive. So, if I am making enable pin I, so then I can treat this as positive signal. So, your latch will respond to the positive duration of this signal. I do not say here clock, it is signal. So, this signal is nothing but a 0 to 1 and 1 to 0 transition once again. So, this latch will respond to this positive level, and if I make enable 0, if I am considering enable signal as 0, then my latch should respond for negative level. So, latches are all we call level sensitive and flip flops are edge sensitive. So, that is the difference between flip flop and latch. So, here we give a signal as clock, here we give signal as enable. Clock is nothing but train of pulses, enable is nothing but a signal. So, it can be a positive edge triggering or it can be a negative edge triggering. It can be a positive level sensitive or negative level sensitive. So, this is the difference, second difference between a flip flop and a latch. Third difference, the flip flop is sensitive to signal change and not only in the level, they can transfer data only at the single instant, and data cannot be changed until next signal change. Means this is one clock period, say T, this is the second clock T1, T2. So, whenever I give any signals or inputs to this latches, this will respond only in this period. Suppose you give the signals, you change the input signals in between here before the next period, this flip flop will not transfer, will not do any change. The data cannot be changed unless until the next signal comes. So, whenever I need to give different inputs to the flip-flop, then I should take care in such a way that it should come at the next clock signal, or else it will be responding for the previous signal itself. Even in case of latch, latch is sensitive to the duration of this pulse and can send data or receive the data when this is on, when it is positive level. So, flip-flop continuously checks its inputs and correspondingly changes its output only at the determining the clock signal and this clock signal. So, it will respond next clock signal, next positive edge, then this is other positive edge. Similarly, so this flip-flop will respond only with respect to the edge, either it could be a positive edge or negative edge. So, in between you are going to change the inputs, still it is not going to change. It remains as it is, whatever the previous data is given. So, it works on the basis of clock pulses. So, it is a function of an input signal latch. It is an edge trigger, it is a levels trigger as I discussed. It changes its next state only with respect to the edge. It changes to its next state only with respect to the next signal applied. So, this is the basic difference between a flip-flop and a latch. So, you can see the difference over here with respect to the edges. Latch versus flip-flop, I have considered here both latch and flip-flop. Latches are sensitive to the positive level. This is the positive level. With respect to this positive level, your output is responded, and similarly flip-flops are sensitive to positive edge. This is positive edge, this is negative edge. So, either I can use positive edge flip-flop or I can use negative edge flip-flop, and this is positive level and over here is negative level. Major differences: level triggered and edge trigger. So, let us discuss now the NOR gate latch. So, how to build a latch, simple latch using NOR gate. So, I am going to take here two NOR gates. So, we have two inputs. So, this is NOR SR NOR latch. So, let us discuss how this latch works here. So, R, S, and we have, as we know, we have two outputs, one is normal and the other is complemented. So, always in latch or a flip-flop, output of the first upper gate is connected as is fed back as an input to the lower gate. So, output of the first is connected back to the input of the lower gate. Similarly, over here output of second NOR gate is connected back to the input of the first NOR gate. So, here we talk about R is nothing but reset, S is nothing but set. So, let us discuss how this flip-flop latch responds with respect to the signal applied. Before discussing this, so since we have combinations, 2 inputs, then we will be having 4 combinations. Let us discuss now one by one how exactly this works. We will write NOR gate truth table before I start analyzing this SR NOR latch. So, first we will discuss what is the truth table of NOR gate. So, NOR gate inputs, outputs. So, NOR gate is opposite of OR gate. So, as we know, in OR gate if any one of the input is 1, my output will be 1. So, it is the reverse now in NOR gate. Any of the input is 1, my output will be 0. So, any of the input to the OR gate is 1, my output will be 1. So, in case of NOR is complement of OR. So, it is nothing but any of the input is 1, my output is 0. So, if both zeros, my output will be 1. This is the truth table of NOR gate. So, now let us discuss what happens when I give inputs to NOR gate. So, now if I am giving both as, let me start with 0 and 1. So, if I am giving S R as 0, S as 1 input. So, let us start with this R as 0, S as 1. So, R as 0, S is 1. So, we are discussing this combination. In this, as we discussed, any of the input to the NOR gate is 1, then my output is 0. So, my input over here is 1. So, obviously, my output will be 0 here. So, if this is 0, this 0 is fed back here. So, both the inputs now 0 to this NOR gate, the first NOR gate, second NOR gate. Both the inputs are 0 now. If both the inputs are 0, my output is 1. So, we will get output as Q as 1, Q complement as 0. So, Q complement 1, 0. My output is 1. We call here the latch has been set. If my output is Q output is 1, this condition now is called as set condition. I say the latch is set, means say that my latch output is at I level, logic 1. So, S1 R0, my output over here is set condition 1 and 0, normal value, complemented value. Say if I make this 0 0, keep as it is the previous condition. If I make this 0 0, so any of the condition can be taken over here. 0 can be here itself, both can be a 0 or either of this is 0. Suppose this is 0, consider my previous value was 1. So, 1 is coming over here, 1 and 0 is 0, the 0 is going back here, it is 1. So, what is happening here? Even though I give 0 0, my output is 1 and 0, means to say that whatever the previous output has been there, it is stored in latch even though I give both the inputs as 0 0. 0 0 condition say no change condition. So, this is nothing but we say the previous condition will be stored here. We call this as no change condition. So, let us discuss now 1 0 condition. So, in 1 0 condition, I make R is equal to 1, S is equal to 0. Let me discuss what will be the output in this condition. 1 and 0. If any one of the input to the NOR gate is 1, my output is 0, as we know. So, here the upper NOR gate output is 0. This 0 is fed back here, 0 and 0 you will get 1. So, my output over here is 0, 1. If my Q output is 0, we call this as reset condition. This is reset condition. So we have here set condition, reset condition, no change condition. Can say that the latch is in reset state, reset mode, reset output, means my output is 0, Q output is 0. So let us check once again. If I apply back 0 0, what is going to happen? So 0 0, say my output is 0 here, 0 and 0, it is 1. So 1 and 0 0 means it is once again no change. Even though I apply 0 1, when I make this to 0 0, whatever the previous condition has been stored, it is retained when I make my inputs 0 0. So that is called as no change condition. So the last inputs are 1 1. If I make both input R and S as logic 1. So as we discussed, NOR gate, any one of the input is 1, my output is 0. So if this is 1, it should be 0, and this is 1, it should be 0. So which is contradictory here, it is violating the rule. As we discussed, output of the latch as normal value and complemented value. So your output here is validating here, it is nothing but both, it's showing zeros, which is not true. It should be complement, 0 or 1 or 1 and 0. So this is violating the rule. So we call this condition as forbidden condition, indeterminate condition, forbidden condition. When both the inputs are 1, you can't predict the output, it is indeterminate, it's invalid. This condition is called as forbidden condition. Similarly, I can build this SR latch using NAND gates. So we have upper NAND gate, lower NAND gate, output Q, complement of Q, input R, input S. So output of the second gate is connected to the input of first gate. Similarly, like this. This is called as feedback connection. So now we are discussing something called as S bar, R bar gate, NAND gate. So what is this? What is the significance? So truth table of NAND gate, we know any of the input to AND gate is 0, my output is 0. So it is reverse of AND gate. So NAND gate is complement of AND gate. So whenever the input is 0 over here, my output will be 1. So this is the truth table of NAND gate. So this is a complement S, complemented R input to the latch. So this is nothing but complement. S bar, if I say S bar is 0, R bar is 0, it is nothing but equal to 1. So we need to take, when I am giving input as 0, so it will be complemented since I am using complement input here. So 1 and 1. So let us discuss all combinations over here for S complement, R complement, NAND gate, latch. We will take the condition 0 and 1 condition. So where your S complement input is 0, R complement is 1. So S complement input is 0, R complement input is 1. So if such is the case, if my input to this is 1, so what should be my output here? it is 1 or 0. If I am giving input as 1, if any n of the input is 0, my output should be 1 in case of NAND gate. So, here it is complement. Since I am giving complement, I should consider when any of the input gate is input R is 1, my output will be 0. So, this is my 0. Since I am giving complement here, I am not giving a normal input, I am giving complement input. So, 0. So, when 0 is connected here, 0 and this will become 1 here since it is inverted. So, 0 and 1 it is logic 1. So, what is my output now? Here it is 1 and 0. So, my output is, if I am giving input as 1 and 0, so my output is S bar is 0, my output is 1. So, this is what we are discussing now. Output of this is 1 and output of R bar is 1. So, this output is, now I can say my output is set to logic 1. Set condition. So, which is a reverse of NOR. So, whenever the S as 1, we got set condition. Now, here invert of this, since my S, invert of S is nothing but 0. Since I am applying 0, I am getting here set condition. So, there S was logic 1, here S was logic 0. So, similarly here when I make this 2, logic 1 is applied here, logic 0 is applied here. So, complement is nothing but this will be 1 and this will be 0. So, any one of the input is 0, my output is 1. So, here it is reverse. So, R complement is 0, my output will be logic 1. If I am applying 0, if it is 1, reset condition. So, similarly if I give both 1 1 here, it is a reverse of SR. So, in this case here, when I apply both 0 0 input to the SR, latch will become 1 and 1. So, here it is for 0 1 it is set condition, this is reset condition and this is no change condition. If you can observe both truth table of S R and S complement R complement latch, you can see the reverse, just it is complemented. So, wherever you can see set condition 0 and 1, it is reset condition over here. So, this is set condition. Let us see the previous one is 1 and 0, this is, sorry, if it is 1 and 0, S is 1 and it is 0, it is in reset condition and it is set condition. In this case it is set condition and it is reset condition. You can just see the reverse of it, since I am using complemented here. So, set, reset, reset, set, 0 0 is forbidden here, 1 1 is forbidden here, 1 1 is no change condition, 0 0 is no change condition. So this is nothing but NAND gate latch. So now let us discuss what is gated or clocked flip-flop. We have discussed SR or RS latch. It can be either communicated as SR or RS. So we have discussed latch. Let me discuss about now flip-flop. So as I said, it is clocked. For a flip-flop, we give an additional input, that is clock, other than the normal input. So block diagram of SR flip-flop or SR latch is written like this, where we have two outputs, two inputs. To this, additional gates will be used. So we have an AND gate. So then I am going to give the inputs here SR along with additional signal enable. So either I can give enable or clock over here. If I am giving enable signal, we call it as gated RS flip-flop. If I am giving enable, then I call this flip-flop call as gated RS flip-flop. So if I am giving clock as an additional input, we call it as clocked RS flip-flop. So this basic flip-flop remains same. Either I can use NOR gate or I can use NAND gate to build this flip-flop. In addition to this, I am going to add a signal through AND gates. So let us discuss how this works. So we have an additional input here, enable, we have S, we have R, Q and then Q complement. So if my enable, I can write two condition, either my enable signal will be high or enable signal will be low. So we will write for all combinations. So whatever may be your input, X represents either it can be 0 or it can be 1. So as we discussed in the previous session, we have whenever my S is 0 and Q R is 1, we have set condition. So S is 0, we have S is 0 reset condition, S is 1 we have set condition, and so when S and R both are 1, so we have forbidden condition. So when both 0 0, it is no change. So we can represent no change as Qn. N represents the same state, whichever the previous state is it's holding, it will be in the same state. So we call it as Qn. So no matter whatever may be the inputs, if my enable pin is 0, enable signal is 0, both the input to the AND gates are disabled. Both the input to the AND gates are disabled. So output of this AND gate is 0 0. So 0 0 will be the input to SR flip-flop. When 0 0 is an input to the SR flip-flop, obviously my output has no change condition. So 0 0 output has no change condition. So whenever my enable is 0, whatever the inputs you give here, since I have the inputs to SR flip-flop as 0, so I will get the output as no change condition. If I make this enable high, logic 1, then both the AND gates are enabled, and based on what inputs you are giving to this, if I take an example, this S is equal to 0, R is equal to 1, I am giving S is equal to 0, R is equal to 1. So, S is equal to 0, R is equal to 1, input to the AND gate is, one of the input is 0, so my output of AND gate is 0. So, and this is 1, this is 1, and I get input to SR flip flop as 0 and 1. So, 0 and 1 condition, it is, once again you are getting the output like this. So, 0 and 1 it is reset condition, 1 and 0 it is set condition. So, based on enable, if enable is high, it acts as a normal SR flip flop. If enable is low, at whatever may be the inputs, you do not get any change condition. So, your output remains in the previous state itself. Since I am using this signal clock or enable through 2 AND gates, so we call it as gated RS flip flop. You can see the timing diagram over here. So, I am applying a clock here, R signal, S signal. When my clock is high, if my R is low, if S is high, R is low, S is high, in the sense it is in set condition, my Q goes high. My output of flip flop is high, since it is in set condition. So, it remains high till the next clock comes. So, here you can just see here, it remains high here till the next clock pulse. Next clock is high, you can see the condition over that at the period of clock I signal, R is high and S is low. When R is high, S is low, my output is in reset condition. So, my output is reset now. Similarly, it follows based whenever the clock signal is high, so your flip flop responds to the inputs and you will get a particular output, either set, reset or no change condition. So, when both the signals are low, here you can see clock is high, both the signals are low, previously your output was held at logic 1, now it remains same. So, this is how the gated clock or gated or clocked RS flip flop works. So, we have another kind of flip flop called D flip flop. So, when I connect this SR flip flop, so D flip flop block diagram is, it has got only single input as usual, a normal value and complemented value. So, I can trigger this flip flop with respect to clock, we call as clocked D flip flop. So, when I am using enable, I call it as gated D flip flop. When I am using a clock, then I call it as clocked D flip flop. So, how the D flip flop is built? As usual, we have SR flip flop built through NAND gates, either NAND gates or NOR gates. So, I connect this through the gated. So, this is S bar, this becomes S, this is R bar. So, we are connecting this to, and I tie this to this is S input, this is R input, I am connecting through. If I short these two signals through NOT gate, I am connecting S input and R input through NOT gate and giving us a single input, that is called as D. So, whenever I short or I connect these two S and R and I treat this as a single input, then this becomes D flip flop. So, the basic internal circuit remains same. Either I can build through NAND gate or I can build through NOR gate. So, if I tie together and connect it to a single gate, then it becomes a D flip flop. So, I connect this through inverter. We have input called D. So, D flip flop. So, what is this D flip flop? Or I can write D flip flop like this. So, this is once again, if I need to connect a clock, I need to use one more AND gate, additional input to connect this 2 through clock, and this is a single input that becomes, you can just see, this remains your SR latch. This internal circuit is SR latch. Outside of this, I am connecting through two NAND gates and input clock. Then I am shorting these two inputs through inverter and I am making this as a single input D. So, inside this circuit, we add SR input, where once again I have taken this clock through two AND gates and I have connected both of these inputs through NOT gate to make as a single input. So, this is called as D flip flop. So, what is this D? Why the name D? D is nothing but data transfer flip flop. It just transfers the data from input to the output, but with a minimum delay. So, we also call this as delayed flip flop. D represents delayed data transfer flip flop. So, let us write the truth table for D flip flop. How exactly this D flip flop works? So, whenever I apply clock, D input, Q and Q complement is the output of the flip flop. So, whenever my clock signal is 0 and whenever I apply my clock signal as 1. So, let us discuss. If my D input is 1, D has either 1 input or 0 input. Since I have got single input here, either it can be 0 or it can be 1. Since my clock is 0, totally your input to the AND gate is 0, means it is disabled. So, when my input is 0, no matter whatever the input you are sending here, either 1 or 0, it remains in the previous state. So, no change. This condition is called as no change condition. So, whenever I am going to apply clock, that is 1, if my D input is 0, then the same thing is transferred at the output with some delay. Of course, there will be some gated delay. So, if I give D as 1, my clock is 1, my output will be 1 over here. So, same thing is transferred at the output when there is a clock signal. So, this is how the D flip flop works. So, this is complement, no change condition when there is clock 0. So, it transfers the output or same whatever the input you are giving, that is transferred at the output whenever I apply a clock. This is how D flip flop works. So, either I can give clock or I can give enable. When I give clock, then we call it as clocked D flip flop. Whenever I give enable as an input, we call it as gated D flip flop. So, it remains once again, if I am giving an enable, if my enable is 0, the same. If I am giving the inputs, there is no condition. If my enable is 1, then I am going to get the output if my enable is 1. So it works here, clock 0, flip flop remains no change, enable 0, flip flop remains no change, enable is 1, D is transferred to the output, clock is 1, D is transferred to the output. This is how D flip flop works. So let us summarize what we have did in this session. So we have discussed about sequential circuit, difference between a sequential and combinational. There is a lot of difference between these two. Combinational only depends on the present inputs, sequential depends on present as well as previous output. So in the combinational circuit you don't have any memory element, in sequential we have a memory element. So what is this memory element, how it is built? So memory element is nothing but which holds either zeros or 1. So we can build this using a simple NOR gate or NAND gate circuits. So whenever I am using 2 NOR gates or 2 NAND gates, we using feedback, it stores either 0 or 1. So we have different types of flip flops, and we call, there is a concept called latch. Latch is a basic element, memory element which stores either 0 or 1. Even flip flop is a memory element which stores either 0 or 1. The difference between flip flop and latch is nothing but flip flop is edge sensitive, latch is level sensitive. So what is this edge sensitive and level sensitive? The way I give a signal, so we call it as a clock signal. Clock signal is nothing but train of pulses. So the clock has got a raising edge and falling edge. With respect to that edge only, your flip flop will respond. So in case of latch, a signal is given, a level signal high or signal low. Based on that, your output or a latch is going to respond to the inputs. So we have got either a flip flop or a latch as a memory element. Basically both is used to store a bit, either 0 or 1. So we have first flip flop, we discussed about RS latch and clocked RS latch. So similarly the RS latch can be built using 2 NOR gates or 2 NAND gates. So difference between a gated and gated SR latch and gate clocked RS flip flop is nothing but a flip flop we give a clock, latch we give an enable signal. So we discuss another kind of flip flop, that is D flip flop, wherein the data is transferred from the input to the output side with a delayed, a minimum delay of the, we call it as a gate delay. So in D flip flop we have got a single input, 2 outputs, that is complement and uncomplemented output. So we have, based on either clock or enable, the data from D input is transferred to the output. So we call it as D flip flop. In the next coming sessions we are going to discuss another kind of flip flop, that is JK flip flop, how JK flip flop works and how it responds. And we have 2 conditions in RS flip flop, that is set condition, reset condition, and 0-0 condition. We don't have any changes in the output side. If 1-1 input is given to the flip flop, then we have a forbidden or indeterminate condition. So let us look into the next session how JK flip flop is different from RS flip flop. So how this forbidden condition is removed over here. Thank you.